Assalamualaikum and hi everyone. My name is Filda. So we are going to represent you guys about photocatalysis. Next. Okay. So photocatalysis is the substrate that absorbs light and acts as a catalyst for chemical reactions. How about the photocatalysis? It is a process where light is used to excite a photocatalyst, and the rate of the chemical reaction is accelerated without involving the photocatalyst. Next. The photocatalytic reactions have been categorized by two types, which is the first one is homogeneous photocatalysis, when both the semiconductor, which is the photocatalyst, and reactant are in the same phase, which is gas, solid, or liquid. And the second type is heterogeneous photocatalysis, which is when both the semiconductor, which is photocatalyst, and reactant are in different phases. So that's all from me. Next, I will pass to next presenter.
Okay, thank you, Filda. So I am Najaha. I will be presenting the reaction mechanism. So this picture in the slide is the summarization of the reaction mechanism of photocatalysis involving three main steps, which is excitation, charge migration, and oxidation. So what is happening in excitation is electron and hydrogen plus pairs are generated on the surface of the semiconductor under illumination with the required wavelength or mg. Next, step 2 is charge migration. What is happening is for the generated charges, electron or hydrogen plus migrate to the surface of the semiconductor. And lastly, oxidation, electron and hydrogen plus induce redox reaction on the surface that facilitate destruction of organic pollutants. After the destruction of organic pollutants, it will proceed the process of degradation and mineralization to produce products, carbon dioxide, water, and etc. Next, I will pass it to Inshi to proceed the presentation.
Okay, thank you, Naja. So I will explain about the reaction kinetics involved for the photocatalysis reaction. So a photocatalysis reaction, it follows Langmuir-Hinshelwood kinetics, where we should know that the equation for Langmuir-Hinshelwood will consider two things, which is the absorption and the reaction steps. So based on this chart, this is reaction steps that Langmuir-Hinshelwood kinetics will follow, where the reactants will adsorb to the catalyst surface, and then it will adsorb to the surface reaction, forming new products. Next, here I listed 5 factors that will increase the reaction kinetics for the photocatalysis reaction, where the first one is the light intensity, where if the light intensity will be higher, the generation of electron-hole pairs will increase, and this will increase the catalytic activity. The second factor is the photogenerated charge carriers. If we have efficient charge carrier transferred to the reaction site, this will also increase the catalytic activity. The third factor is the catalyst band structure, where if we have the good band structure for our catalyst, the photo-generated charge carriers will have enough energy to participate in reactions. The third one is the surface area. If our reactants have a high surface area, it will provide more active sites for the absorption, then the reaction will occur more progressively. The final factors here is the temperature. If the temperature is high, the absorption kinetics will also be higher, and then the reaction rate will be higher. So that's all from me. I will pass this to the next presenter.
So my name is Nurulina. So I will continue by presenting on an example of titanium dioxide based photocatalytic reaction. So I choose the oil field produced water. So oil field produced water is actually really carcinogenic and also high toxicity to marine living things, which we need to avoid it. So next is there is a diagram that showing the mechanism that involved in the titanium dioxide in photocatalytic reaction. So basically, these involve two main steps, which are the photoexcitation of the semiconductor and also involve the migration or the recombination of the charge carrier with the emission of heat or light. So these, as I mentioned before, these are the reaction mechanism that represent the mechanism of the titanium dioxide as the catalyst in the photocatalytic reaction. Next. So we want to highlight on focusing on the general process of organic pollutant degradation, which involve four steps, which the first one is generation of charge carriers, second is trapping charge carriers, third is charge carrier recombination, and the fourth is interface charge carrier. So here we attach the reaction mechanism equation that basically related and involved in the organic pollutant degradation by the titanium dioxide. So that's all the example of the titanium dioxide as the catalyst in the photocatalytic reaction. So next, I pass to the next presenter.
Thank you, Irina. My name is Aina Nazira. Okay, so I will proceed with the example of non-titanium oxide-based photocatalytic reaction. So the example is photocatalytic degradation of methylene blue. So the photocatalysis used is zinc oxides and the target pollutant is methylene blue. We know that methylene blue is a commonly used dye in various industry. So the reaction involved if when zinc oxide as catalyst react with light HV and react also with methylene blue, so produce a degradation products. Okay, the next slide, the mechanism involved is in 6 steps. So first step is light absorption. So we know that zinc oxide is a semiconductor material with a wide band gap. So when exposed to light, so it's the ultraviolet range, so it absorbs energy and excited to the conduction band. So the next step is generation of electron hole pair. And then next is it then undergo the reduction and oxidation, and both will produce hydroxy radical. And this radical play a crucial role in the degradation of methylene blue by breaking down its chemical structure. The fourth step is the generated reaction species, including hydroxy radical and superoxide radical interact with methylene blue molecules. The fifth reaction is degradation of methylene blue. And then last but not least, the degradation products further undergo process of mineralization, where they are converted into simpler and more environmentally burning compound like carbon dioxide, water, and other inorganic species. So that's all about the example of non-titanium oxide space photocatalytic reaction. I think that's all for our presentation about photocatalysis. Thank you for watching.
Thank you, everyone. Bye-bye.
Bye-bye.